Hi viewers, you're my great students. It's so good to have you watch the very fifth video of our UTMB video series. It's so great to have you once more. This time around, we'll be looking at a very great subject, logarithm. This time around, we're going to look at in-depthly some rules guiding the solution, guiding logarithm, which we all need to know. But before that, last time I left some quizzes for you to go about doing. They are all on indices. Did you try them? I guess you did. I want to believe you did. And I know you've been able to know that solving indices, especially when you're giving such questions in your exams, is pretty easy. Now, if you have any difficulty solving that, feel free to throw the questions to us. We'll help you, we'll assist you solve it. Today, we're going to look at a different topic entirely. But if you have done those quizzes, on the screen, you'll see the answers displayed. Check it through with what you've done. If they are correct, then you let us know. If they are not correct, check our ebook series and see the correct solutions to those questions. I'll be right back to take you on our topic for today, logarithm. Stay tuned. Welcome back. Our topic for today, as I told you earlier on, is going to be logarithm. Many students find this topic so difficult. Why? Because most of them, especially when you are giving such questions on the objective parts of your examination in the UTME, you will not be required to use the logarithm table, which is more of those tables we are used to using then in school. But then we're going to look at how we will use the rules guiding logarithm in solving questions. Now, if you follow through this topic for today, you should be able to do the following. 1. Solve problems in different bases in logarithms. And 2, which is the final one, establish the relationship between indices and logarithms in solving problems. Before we delve properly into this, as is a routine in our videos, we want you to look at the challenge questions for today. They are great questions and I want you to look at them. Can you truly solve them? Let's check out. Now you see those 3 questions displayed on the screen. They seem pretty difficult, right? But stay tuned and stay locked in to the end of these videos. You're going to see real-time solutions to these questions. I won't tell you they are pretty simple, then we are going to solve them together. But before we go further, let's delve right into the topics for today, which is logarithm. What is logarithm? Logarithm is the exponent or power to which a base must be raised to yield a given number. And it is expressed mathematically as, let's assume we are given a value b raised to power x equal to n. X is going to be the result of log of n base b. That is, log n base b is equal to x. So in general, if we say a raised to power x is equal to y, then log y base a will be equal to x. Now, for example, if you are asked to find the value of log 81 base 3, you will come to see that an exponent of 4 is needed to make 3 in 81, So that means 3 raised to power 4 will be equal to 81. So log of 81 base 3 will be equal to 4. Remember the definition we gave logarithm, that logarithm is the exponent or power to which a base must be raised to yield a given number. So that value will be equal to 4. Now we are going to look at the keynotes below. From the keynotes we'll be taking on today's topic, you will be able to find out some rules that will aid you in solving questions in logarithm. Note that you will not be given questions that will require you checking logarithm table, as it is always a rule in the West Africa Examination Council, that is the WAEC, which I know you have just finished. So as a UTME student, all you need to do is to familiarize yourself with these rules of logarithms. Now I want you to pay attention to the following keynotes. Keynote 1, logarithm product rule. Now that rule states that if you have a log of mn base a, the result will be equal to log of m base a plus log of n base a, which is similar to the product law of indices. Now, rule number 2 says the quotient rule. When you have a log of m over n base a will be equal to log of m base a minus log of n base a. Log of the same base, similar to the laws of indices too. Now we look at the third keynote. When we have power, logarithm power, that is raising to a power. When we have log m raised to power p to base a, the result will be equal to p multiplied by the log of m base a. Take note of that, because we usually have questions a lot from this keynote, this rule, the raised to power rule. Now we want to look at the fourth rule. The fourth rule is logarithm root. The root of the nth root of the logarithm of the nth rule. Now we want to look at the fourth rule, the logarithm root. The logarithms of the nth rule of a number is the logarithm of the number divided by n. How do we mean by that? If you look at the screen, if we have a log of n root m base a will be equal to the log of m base a all over n. You will see this being used in the sample questions we'll be giving you. The fifth keynote says logarithm base switch rule or reciprocal rule. When we have a log of n base a, it can be equal to 1 over log of a base n. So do you notice that the base and the root are switched? That is exactly what the rule is all about. We'll look at rule 6, logarithm base change rule. Now that rule says we'll have log of x base b, it can still be equal to log of x base c all over log of b base c. Now the seventh keynote says logarithm zero rule. When we have a log of 1 base a is equal to 0, or we can say a log of 1 base 2 is equal to 0. It's similar to the law of indices that say anything raised to power 1 is equal to 0. So when you have a log of a base raised to power 1, the result is 0. Finally, we'll look at the final rule, base raised to power its own value. Log of a base a is equal to 1. That same thing goes with we having a log of 10 base 10. 10 base 10, log of 10 base 10 will be equal to 1. So I want you to pay attention to these following keynotes. These following keynotes are so important because once you come to know these rules and you have them in your fingertips, you can be able to solve any question in mathematics as long as it is a logarithm question that does not involve the use of our 4-figure table. Now let's go ahead to look at some few samples for today. We are going to take just 3 samples and I want you to pay more than the usual attentions to this sample. And I promise you, like the challenge question we've always been taking, if you stay tuned to the end of this video, you are going to see how these questions are so simple to solve. Now let's start. Sample question 1. Alright, now let's look at the first sample question of this topic, logarithm. Now, if we look at this first sample question, you are asked to look for the log of 4 base 10. They say the log of 4 base 10 is equal to 0.6021. You are asked to evaluate log of 4 raised to power 1 over 3 base 10. Now, how do we go about this? Now, the first thing I want to remind you is for you to recall the fourth keynote that says logarithm with roots. If you have a logarithm with a root, that's m root 5 of base a, it should be equal to log of that base a raised to power the value over the root. Now let's apply that here. We are given a value, we are asked to evaluate log of 10 for 1 over 3. Now remember, if you have a value a raised to power 1 over 2, it should be equal to square root of what? A. Same thing goes here. If you have a raised to power 1 over 3, it should be equal to the cube root of what? Of a. We are going to apply that here. So this value now will be equal to log of what? 10 raised to power the cube root of 4. Now, if we take that, compare that to this equation, you will come to find out that our n is 3, our m is 4, and our a is 10. Now, let's apply this equation from rule 4. That is the logarithm of roots. We know that this is equal to this. So let's bring it back here. We'll have our log of what? 10 cube root 4. That will be equal to what? We have our log of what? The 10 raised to power the what? The m raised to power 4 divided by what? By 3. Now notice that they told you that your log 4 base 10 is equal to this value. So this will give us 0.6021 divided by what? 3. Now if you divide this value 0.6021 divided by 3, if you divide it, you're going to get a value 0.2007, and that will be the value of that evaluation. Your result will be 0.2007. I guess you have a calculator there. If you have, divide this with a calculator. Remember, in your JAMB, you'll be given this business calculator, not the Casio type. So if you use that on this, you're going to get this value, and you can equally simplify this using your normal divisional method. You'll also be able to get this. So this is the solution to that questions up there. Now let's look at the second sample of the day. I hope you understand this. Now let's check out the second sample for this topic, logarithm. Alright, let's look at the second sample question. If log x squared base 3 is equal to minus 8, what is the value of x? What is x? Now, if you are given this, recall a sample that a logarithm law that if you have x raised to power x is equal to 2, that your x will be equal to a raised to power 2. We're going to apply that here. So if we have our log of x squared base 3 equal to minus 8, our x squared now will now be equal to 3 raised to power what? 8. Now remember, we're looking for the value of x. Now to look for the value of x, this is a square root. We need to what? This is a square. We need to square root both sides. Now, how do we go about square rooting both sides? If we square root both sides, we are going to get this value. Square root of what? Raised to power 2 equal to square root of what? 3 raised to power minus what? 3 raised to power minus 8. So if we clear this, This will cut this. Our x now will now be equal to the square root of what? The square root of 3 raised to the power minus 8. Now we can clear this further. This, you should recall that square root of 8 can be equal to what? A raised to the power 1 over 2. The application of most of these rules will help us go about solving this. So our x now will now be equal to 3 raised to the power minus 8 times 1 over what? Over 2. Because the square root now has become 1 over 2. So 2 will cut this to give you what? 4. So our x now will now be equal to 3 raised to the power minus what? 4. Simplifying this further, we'll have our x to be equal to 1 over what? 3 raised to the power what? 4. And 1 raised to power 1 over 3 raised to power 4 is like you saying 1 over 3 times 3, 9. 9 times 3, 27. And 27 times 3, 81. So our result will be equal to 1 over what? 81. So our x here will be equal to 1 over 81 if it is properly evaluated. So you see, applying the rules, the various rules, these rules, I didn't get them anywhere. It's from studying the rules of logarithm. If you can get to know these rules and bring them out, let them be at your fingertips. Each time you have any similar struggle, you know the rule to apply to break out the gene that is there. So if you can apply this rule, you can easily apply them when solving logarithm table, questions on logarithm, and you get your solutions easily. You see how easy it can be. Now I want us to look at the final sample. Though it might be lengthy, but I want us to take it little by little. We'll finally arrive at the solution. We'll look at sample 3. Now let's look at the final sample question for today. Now it's going to be a lengthy question, as I said, but then we'll take it bit by bit, and with easiness we can be able to easily get to arrive at our final answer. Now let's look at this. We are given log 7.5 to be equal to 0.8751, right? And you are asked to evaluate 2 log 75 plus log 750 as displayed on the screen. Now, if we are given this value, you should note that we have our 7.5 times 10 on normal mathematical level. That will give you 75. And 7.5 times 100 will be equal to 750. Now, see how we are going to apply this logic we've just arrived at in solving this. Now, you are given this question. Recall that we have 2 log 5 is still equal to 7.5 times 10. So that will give us, we'll take all the logarithm to base 10. That will give us 2 log 10 into bracket 7.5 times 10, right? Plus log of 10 base bracket 7.5 times 100. I wanted to minus this board, but let's see how far we can go with it. So that will give us this value. Now, if we break this part, remember the first keynotes, 7.5. Remember the first product law of logarithm. We'll have 2 log 10 raised to the power 7.5 plus log of 10 base 10. That will be plus log of 10 base 7.5 plus log of 10 base 100. Now, if we simplify this further, we are going to have 2 into bracket log of 10 7.5 base 10 plus log of 10 base 10 is what? 1. But we're not going to do that now. Let's still write it out. Plus log of 10 base 7.5 plus, remember we have log of 100 base 10, so it's going to give us log of what? 10 base 10 2, because raised to 10 raised to power 2 base 10, because 10 raised to power 2 is what? Is 100. I guess you get that. Now let's look at that. This is going to give us 2 into log of 7.5 plus log of what? 10 base 10, hope you're following, plus log of 10 base 7.5 plus, now when we have a something like this, 10 raised to power 2 base 10, it can still be equal to 2 what? So if we apply that here, we're going to have 2 log of what? 10 base what? 10. Now if we simplify that further, come to know now that 7.5 log 7.5 is equal to 0.8751, and we know that our log of what? 10 base 10 is equal to 1. So simplifying further, we'll have 2 equal to 0.8751 plus 1, right? Plus 0.8751 plus 2 times 1. That will give us 2. So if we add these two together, we are going to have 2 into bracket 1.8751, right, plus 2.875 So this multiplied by this will give us 3 point, I guess you are seeing it, 3.7502 plus 2.875 Now if you add these two together, if you add these two things together, let's go. 2 plus 1 will give us 3, right? 5 plus 0 will give us 5, right? 7 plus 5 will give us 12. We'll carry 1 over. 8 plus 7 will give us 16. 15 plus 1, that will give us 16. We'll carry 1 over. Then 2 plus 3 will give us 5 plus 1, 6. So that means we minimizing of the final result will be 6.6253. You see, that's the final solution of this value. So remember, we are requested to evaluate. Now, these 3 samples is enough for you to see various aspects through which we can get to solve questions on logarithm. For a handful of such solutions or such sample questions, find out, check our ebooks, New Track Mathematics UTM/JAMB Series 1. You'll get a handful of these questions, and you can try so many other questions. Behold, our quizzes, 6 questions are out there and they are displayed on the screen. Try and check out this quiz question. Try and work out on them. See how you can solve them and further questions. I will look forward to seeing you in our next video, and I promise you the next video we're going to look at standard form. It's going to be an interesting outing, and I want us to look out for it. Standard form, and make sure you stay safe and continue viewing our video. I'll see you some other time.